Hey guys, welcome to section 4, chapter 3 of the geometry program. And in this section, we're going to work on something called polygons. Last section, we talked about triangles, and triangles are a form of polygons. But by definition, a polygon is a closed plane figure with at least 3 sides that are segments. The sides intersect only at their endpoints, and no adjacent sides are collinear. So yeah, again, we have a really dense definition, but the application I think you'll find is very easy. Okay, so here is an example of a polygon. So a polygon lies on the same plane. It's closed, meaning all the endpoints come together, and they only intersect at those points. So this would be an example of a polygon. Something like this is not a polygon. Why? Because it's not closed. It's not closed here, right? We want the shape to be closed. Neither is this a polygon. Why? Because it intersects here. The segments intersect at some place other than the endpoints. They intersect, not just at endpoints. Okay, so it can't be open like in the second case, and they can't intersect anywhere other than at the endpoints in order for it to be a polygon. All right, so once you have identified what a polygon is, how do we name it? So let's call this one A, B, C, D, E, F. First, you have to identify what the vertices are. And remember, the vertices are these points where the segments come together. So the vertices are simply A, B, C, D, E, and F. And that's how we would name this polygon. This would be polygon A, B, C, D, E, F. Okay, it's named by its vertices. And then just as a good review, can you name the sides? So just be systematic so you don't lose a side. So that would be side AB, side BC, CD, DE, EF, and then FA. Now, technically, we would put the bar for the segments over this. I'm not overly concerned with that when we're dealing with polygons. It's probably a good practice to do it, but I won't necessarily mark you off on a quiz or test at this point if you forget the bar. All right. And then just a review of how we would name angles. The angles could be either just angle A, angle B, angle C, or we could name them by 3 vertices, right? So angle ABC would be this guy. Angle DEF would be this guy, right? DEF. So the angle is the letter that's in the middle. Or angle FAB would be angle A. So 2 ways to name them, and just as a good review. All right, once we know what a polygon is, there's 2 other types of polygons, or we can describe them either as convex polygons or concave polygons. So a convex polygon is a polygon that has no diagonal with points outside the polygon. All right, I'm going to draw you just 2 quick pictures. It might not make sense to you until you see the concave or something like this. Okay, you can draw diagonals here and point to endpoint. Everybody is good. Everybody's happy. This would be a convex. All right, but a concave could look something like this. This by definition is a polygon because it's closed It only connects at the endpoints, right? But as I draw these diagonals, I could draw a diagonal outside the shape. That's what makes it concave. Or sometimes students might see like caving in as a way to distinguish between convex and concave. So if it pulls in like that and you can make an outside diagonal, then it's concave. All right, you're going to get practice identifying different ones. All right, and then we have something called the Polygon angle sum theorem. Big fancy name. The Polygon angle sum theorem is the sum of the interior measure of the angles of what's called a nonagon is used by this theorem. All right, so easier way we might write it is sum equals n minus 2 times 180. And n is the number of sides of your polygon. Okay, so you might be like, again, ooh, that seems crazy. All right, but it's really not bad at all. Let's say you have a 12-sided figure. We'll call it a 12agon. Another name for that is a dodecagon, which is super fun. So that might be worth noting. Dodecagon is a 12-sided figure. And then in order to find the sum, all we have to do is plug this in. So the number of sides, of course, is 12. That represents n minus 2 times 180. So all you have to do is remember that parentheses come first when doing our order of operations. So this needs to be 10 times 180. And that, of course, is going to give us actually just 1800 degrees. So this is degrees. You're looking for the sum of the interior measure of the angles. So the total measures inside, I'm not actually going to draw a dodecagon, but what you're looking for is adding up all of these angle measures for the total. Okay, and then, I mean, what if we had something like a 16agon? That seems crazy, right? But could happen. So the sum would equal 16 minus 2 times 180, which would be 14 times 180, which would be 2,520 degrees. So in your homework and on tests or quizzes, you might be given examples with just a shape and you have to count up the sides so you know what your n is. Or you might be given just a numerical value here, like a 12agon or a 16agon. So you might get a picture where you have to add the sides, or you might just be given the shape name. Okay. All right, so the total measure of those interior angles is given by this formula. But sometimes we just want one interior angle measure. Okay, so if we use the 12agon as our guide, we know that the total sum is 1800. So if I wanted to find just one, I could take 1800 and divide it by n, how many sides we have, right? So in this case, it's 12. And if I take 1800 divided by 12, I'm going to get 150 degrees. So that would be the measure of one angle in a dodecagon. Okay. Similarly, if I have a 16agon, we just found the sum for that, which would be 2,520. So obviously you have to find the total sum first, then divide by how many sides you have. So in this case, our total sum measure was 2,520, but now we have 16 sides. And so then my angle measure would be 157.5 degrees. This is one angle of a 16agon. Okay, so to find the sum of the angle measures, you use this formula. To find one interior angle, you have to first find the sum, then divide by the number of sides you have. All right, this is important, and it's subtle, but you have to read carefully with your directions. The math is really easy, but you can confuse what you're supposed to do when and mess up pretty quick, okay? All right, so those are the interior measures. Well, of course, then we have to deal with the exterior. So the Polygon exterior angle sum theorem is the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So basically what that means is if you extend each of these angles, the sum of all of these angles is going to be 360, which makes sense, right? Because I just drew that circle and we know that the distance around a circle is 360. So in order to find the measure of one exterior angle, all you have to do is take 360 and divide by the number of sides you have. So if you had a pentagon has how many sides? Good, 5. 5 sides. Then you would take 360 divided by 5, and your exterior angle would equal 72 degrees. Okay, what if we had an octagon? An octagon has how many sides? 8 sides. So you take 360 divided by 8, and then the exterior angle would be 45 degrees. All right, so try to keep this straight. When you're dealing with exterior angles, think of the circle, which has a value of 360 degrees. That will help you remember that all you have to do is take 360 divided by n. 360 divided by n basically is your formula here. And if we go back up, the interior angles are the sum equals n minus 2 times 180, and then divide that by n if you need one of the interior angles. Okay, I know that was a lot, but I don't think that the assignment should be too challenging. So go ahead, finish up your notes, read through the examples, and begin your assignment.